Hello friends, in this video, let us analyze the time and space complexity of the selection sort algorithm. In the previous videos, we have learned what is selection sort and how to implement it. So selection sort algorithm is generic for all the input cases. That is, whatever the input sequence may be, it will follow the same procedure. So the time complexity will be same for both best and worst case. So let us analyze the time complexity first. Let us assume the array size is 5. For the outer loop, when I equal to 0, the inner loop will be executed for j equal to 1, j equal to 2, j equal to 3 and j equal to 4. That is from I plus 1 to size minus 1. So in first iteration of outer loop, the inner loop statement will be executed 4 times. Next, when I equal to 1, the inner loop will be executed from j equal to 2 to j equal to 4. That is 2, 3 and 4. So in the second iteration of outer for loop, the inner loop statement will be executed 3 times. Next, when I equal to 2, the inner loop will be executed for j equal to 3 and j equal to 4. That is 2 times. Next, when I equal to 3, the inner loop will be executed only 1 time for j equal to 4. So in fourth iteration, we have only the inner loop statement executed for 1 time. Next, when I equal to 4, the condition will fail and the outer for loop will stop its execution. So when size equal to 5, the total time taken is t of x equal to 1 plus 2 plus 3 plus 4, which is size minus 1. So in general, when size equal to n, t of x will be equal to 1 plus 2 plus 3 plus etc. plus n minus 1. And what is the sum of natural numbers from 1 to n? It is n into n plus 1 by 2. Here we have 1 plus 2 plus 3 up to n minus 1. So the last number is n minus 1. So replace n as n minus 1 in this equation and we will get n minus 1 into n minus 1 plus 1 divided by 2. And this minus 1 plus 1 will be cancelled. So this equation will become t of x equal to n minus 1 into n divided by 2. That is n square minus n by 2. So we got the time required. Now how to get the time complexity here? Just find the highest exponential and it is n square here. So the time complexity of selection sort is order of n square. And as we said first, the selection sort algorithm will behave the same for all kind of inputs. So here, best, worst and the average case time complexity will be the same order of n square. Now let us do the space complexity analysis. The space complexity is the total amount of space a particular algorithm takes to produce the output. So here, array ARR takes n units of memory and the size variable will take 1 unit. And we have the variables I and j, each will take 1 unit of memory. So the total memory space required is n plus 3 and here the degree is 1. So the space complexity will be order of n. Now let us discuss about the auxiliary space complexity. But before that, what is auxiliary space complexity? See, the auxiliary space is the extra space or the temporary space used by an algorithm. Here the array ARR and size are the given inputs. The extra memory used by selection sort algorithm is I and j. 1 unit of memory is needed by I and 1 unit of memory needed by j. So total space is equal to 2 units. That is a constant. So the auxiliary space complexity is order of 1. And if a sorting algorithm sorts all the elements without using extra memory or sorts all the elements with auxiliary space complexity as order of 1, we can call that sorting algorithm as an in-place sorting algorithm. So selection sort algorithm is an in-place sorting algorithm.